A professor of chemistry with an international reputation as a research chemist was preparing an experiment that involved the use of dimethylmercury. The professor spilled a few drops of the compound on her gloved hand, but thought the latex gloves would be protective. They proved to be inadequate, and the toxin passed through the glove and was absorbed into her system. 6 months later, she slipped into a coma and died from acute mercury poisoning. A young research assistant at a West Coast lab was working with a pyrophoric chemical, T-butyl lithium dissolved in a liquid. While using a syringe to withdraw a quantity of the reagent, she apparently pulled the plunger completely out of the syringe barrel and spilled liquid onto her synthetic sweater and nitrile gloves. Introduced to air, the liquid ignited immediately, and she sustained second and third degree burns over 40% of her body. She died 18 days later of those injuries. 2 researchers lost, to their families, to the world of science. While the university provides all of the tools to assure you of a safe work environment, it is ultimately your responsibility to work safely. The goal of this lesson is to increase your awareness of the physical, chemical, biological, and radiological hazards that can be part of any laboratory environment. In following lessons, you'll learn about engineering and administrative controls and what personal protective equipment requirements are necessary to protect you and others who work in the laboratory, as well as general guidelines for working safely. Universities have set goals of establishing and maintaining a strong safety culture, and many have adopted an integrated safety and environmental management system to support this goal. The Integrated Safety and Environmental Management (ISEM) program is used to enable safe science by giving researchers the tools to perform a comprehensive risk assessment. ISEM uses principles compatible with the scientific method to help workers fully assess the safety hazards present in their experiment and to identify and implement the controls necessary to create a safe work environment. Please review the 5 steps of integrated safety management as well as the initial questions you should ask at the beginning of every experiment. Notice that you start by defining the scope of your work. This is the step in which you plan the experiment by identifying the chemicals, equipment, and procedures that you will be using. Ask questions, if necessary, to learn the properties of chemicals and steps in the laboratory procedure. As you continue through the course, you'll follow this ISEM model to learn about the other steps, including the identification of hazards, development of controls, and the practices needed to safely perform research.